Okay, let's start our class. Our class is about the electromechanical microcontroller technology. This is my name, Ji Junyi. This is my WeChat. This number. You can connect me with the WeChat. Electromechanical microcontroller technology, which means in Chinese we call it 机电微控制器技术机电微控制器技术。And in this class, programming and microcontroller fundamental, we will tell you something about the programming and the microcontroller fundamentals. Electromechanical, which means mechatronicals, mechanical electrical integration. It's electromechanical, which means we use micro control machine, control machine. Sometimes we call microcontroller with the microcontroller unit or single chip micro computer, microcomputer, SCM or MCU is all their means. Their mean microcontroller, microcontroller. Okay, let's have the first chapter. First chapter. Introduction to computer and microcontroller. Microcontroller. History of computer. History of computer. Initially, the word computer refers to a person who performs the task of computation of all calculation by the end of the 19th century. The same word refers to a machine that performs the task of computation or calculation. Computer is equal to hardware and software. Computer hardware is based on binary digital logic, invented by the Claude Shannon in 1937. Binary digital logic is based on the theory of Boolean algebra. Some information you didn't know about the bits, bytes, word, and double word. Is the unit, fundamental unit we use in the computer. Bit, one bit. It's a byte. Byte is 8 bits. Word, sometimes word is 2 bytes. 2 bytes. Double word 2 words. Double words 2 words. Is the information units for the computer. And in the 8051 microcontroller, we have the bits and bytes, bit and bytes for the use as the information unit, information unit. Computer hardware, computer hardware. Hardware consists of processor, input devices, output devices, and the memory. Hardware, processor is designed to execute a set of machine instructions. Processor. A machine instruction is a sequence of zeros and ones, which can command the processor to perform certain operations. It's a processor. Memory used to hold the program to be executed and the data to be processed. Memory. Input devices allow data to be entered to be processed by the processor. Output devices provide feedback to the users by displaying the program execution results. Output device, input device. Output device sometimes is a display, printer is the output device. Input device is a keyboard, mouse, mouse. Computer software, computer software. Software is the program to be executed by the computer hardware. A program consists of a sequence of machine instruction. Machine instruction. A machine instruction is equal to operation code and operand. Operation code operand. After we know something about the microcontroller, we use the assembly language, to make a program. So the assembly language is the instruction is equal to opcode and operand. Stored program concept is the most important feature of the computer. By changing the stored program, the computer hardware can perform unlimited numbers of operation, which means we can change the program running in the microcontroller, so we can get the different function. The earliest computer program is change the wires and the switches of the hardware. Before we use the program language to make a program. Before that, we just change the wire and the switch to change the function, change the functions of the hardware. So after we can change the, we can use different language to make a program. We just use the different program. We can running different function, Today's program are represented as files of text, which means if we make a program, we just write the code in the text files, computer architecture. Computer architecture. In 1945, John von Neumann proposed the stored program architecture. Stored program architecture is also called von Neumann architecture. The one Neumann architecture is shown in this figure. In this figure, one Neumann architecture. This architecture is memory, control units, ALU, input and output. This is Harvard architecture. From the two figures we know, figure 1.2a and 1.2b, we know there is two architectures, Harvard architectures and Neumann architectures. The Neumann architectures is shown in figure 1.2. In this architecture, data and the program are stored in the same memory. Data and the program saved in the same memory. But in Harvard architecture, it's instruction memory. It is the data memory. A deviation from one new main architecture is Harvard architecture, in which data and programs are stored in separate memory. Harvard architecture allows the data and the program to be accessed at the same time. This feature is very important for improving the computer's throughput. Sometimes we know the Harvard architecture is faster than Neumann architecture. Next, I introduce the computer programming language. Machine language is a machine program consists of a sequence of machine instructions. A machine program can be executed by computer directly. Programming productivity is extremely low. Machine language is consists of machine instruction. If machine instruction is difficult to remember, so if you want to use the machine language, you need to have a reference book to use the machine instruction. Assembly language. This language we need to use in this class. Consists of assembly instruction. This is a machine instruction. And assembly instruction is derived by representing each machine instruction. Using a symbolic name. This means the assembly language is the same to the machine instruction, but we can remember the name with the symbolic name, An assembly program is a sequence of assembly instruction. An assembly program must be translated into machine program before it can be executed by the computer. Means when the assembly language program is executed, it needed to be translated into machine instruction. The translator for the assembly program is called assembler. Translate for the assembly program is called assembler. Programming productivity is also widely known. But the assembly language is can be remembered easily. This is an example for the example of 8051 machine and assembly instruction. This is a machine instruction. This is assembly instruction. So this is consists of 0, 1, 0 and 1s. As a instruction, we can remember with the symbolic name. So this code executed gets the same result, but we can remember this. High-level language. High-level language are invented to be improve productivity. Program reading in high-level language are either compiled or interpreted. Which means before the high-level language can be executed, it needed to be compiled or interpreted. Programs written in interpreting languages requires an interpreter execute the program. The interpreter performs the operation specified by the program without translating to machine instruction. Language such as Basic, Lisp, Python, Java are examples. Programs are written in compiling language require a compiler to compile the programs into machine instruction. Before they can be executed, some languages such as C, Fortran, Copper are compiling languages. C languages. C languages. After we are familiar with 8051, we use C51, U51 as a programming language. This high-level language can be helpful for you if you want to make big programs. Next, I introduce the types of computers. Mainframe computers are mini computers, microcomputers, and personal computers, server and supercomputer. Mainframe computer. Earliest computers are called mainframe because they are made of vacuum tubes and are huge in size. Vacuum tube. Very expensive and hence only large organizations and companies can afford them. Also used to distinguish high-end computers. From less powerful computers. Mainframe computer has a lot of storage serving simultaneously many users through terminal stations. Many users. The computer time, the CPU time is divided into slots with each time the slots are assigned to one user. Mainframe computer market is dominated by IBM 160 compatible product lines. Mainframe computer IBM 360 was introduced in 1965. User can start small and upgrade later on. The IBM 360 computers are software compatible and can run the same program disregarding their memory and performance. In 1960, IBM 370 was introduced as the upgrade for the IBM 360 family. IBM 390 was introduced to replace the 370. The latest IBM mainframe family is of August 2013 is the System Z. These computer systems can run the same software. Software compatible. The features of mainframe computers: high reliability and security through redundant design. Extensive inputs and output devices enable the use of many different types of I/O media. Software compatibility. This guarantees the Success of products are high utilization rates support massive throughput rarely went down. Repairs and hardware upgrade can take place during normal operation due to redundant design. And this is features for the mainframe computers. Here I introduce the mini computer. Mini computer smaller than mainframe computers in size and were introduced in 1960s. Smaller by using transistor, core memory and integrated circuits. Earlier mini computers took up one or a few cabinets of a larger refrigerator. A few. This is the first successful mini computer was introduced in 1964 by DEC. Major mini computer vendors include Apple Computer, Data General, DEC, HP, Peking Elmer, Prime, and one laboratory. Starting from late 1960s, the 7400 logical ICs were used in mini computers. In 1980s, mini computer used VLSI chips. Very large scale integrated circuits. Which means the mini computer is smaller. When you use the VLSI chips. Mini computer in 1980s, many mini computers become 32 bits and were called super mini computer. DEC is the most successful mini computer company. DEC is the most successful mini computer company. Mini computers were forced to die by PC and servers. Which means now the mini computer were dead. Mini computer is the former of PC and the servers is the PC and the servers. Microcomputer, a computer that used a microprocessor as its CPU. The first batch of microcomputer appeared in 1970s. The earliest microcomputer came with as little as 256 bytes of memory and no I/O devices other than LEDs and switches. In the middle 1970s, microcomputers grew faster and cheaper. It's the most successful microcomputer company. This is the microcomputer company. Microcomputers we used to run business applications such as accounting, database management, and word processing. Our user PC sometimes is we call it a microcomputer. Some microcomputer were single use. Others are multi-user. Apple II was introduced in 1977 and became one of the most successful computers in the history. Apple II has many clones due to its huge success. Macintosh introduced in 1984, was the successor of Apple II. Mac has gone through several generations and has used several different microprocessors, including Motorola and Power PC and Intel Pentium. Mac has many forms: desktop, laptop, and all-in-one. Microcomputer IBM Pc was introduced in 1981 and used the Intel 8088 as its CPU. IBM Pc used off-the-shelf components OS from Microsoft. IBM Pc was a big success and has many clones. At the end, there are many IBM Pc clones than the original IBM Pc. The word PC has been used to refer to the IBM Pc compatible. Our user PC is IBM compatible. IBM sold its PC business to Lenovo in December 2004. 2004. Next, I introduce the supercomputer. A computer with the speed of computation at the front end. The first supercomputer was introduced in 1960s by CDC and designed by this company. In the 1960s, supercomputers only ran instructions much faster than the other type of the computers are. In the 1970s, most supercomputers are vector processor in which one instruction can operate on multiple data items. In the earlier and mid 1980s, saw machines with a modest number of virtual processors working in parallel to become the standard. Working in parallel. In the late 1980s and 1990s, attention turned from virtual processor to massively personal processing systems made of thousands of either of the shelf ordinary commercial microprocessors or customer microprocessors. These microprocessors are grouped into cluster and connected using custom interconnect. US is the leader of supercomputer. Is the leader of supercomputer. At the beginning, Japan made a major stride in the supercomputer field in 19. Sorry, we have a break. You can have a rest.
Okay,
Okay.
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 哎，没了，怎么了？
진짜.
Hello? Can you hear me?
Yeah, 老师。
老师。
Yes, 老师。
Okay, thank you. Let's continue our class.
Okay, 老师。
I noticed that some people haven't renamed their name, meeting name with their student ID and their name, real name. So if you are there, I hope you can rename your meeting name to your student ID and your real name. Part of your real name is okay.
Student number is sufficient.
Yeah, student number. You need to rename your meeting name to your student number and your real name. And your real name.
Okay.
Let's continue the class. Class. Last class I introduced the supercomputer. Supercomputer. Japan. First, US is the needle of the supercomputer field is the beginning. After that, Japan made major strides in the supercomputer field in 1980s and 1990s. In 2010, the Tianhe-1 becomes the fastest supercomputer in the world. For 1 year. In 2011, Japan's Fujitsu key computer became the fastest computer for 1 year. Tianhe 1 is belong to the Chinese. Belongs to the Chinese. Supercomputer continue on. In 2012, two US supercomputer held the crown. This computer. In 2013, Chinese Tianhe-2 become the fastest computer for 3 years. In 2016, Chinese Sunway Tianhu Light became the fastest supercomputer and held the crown for 2 years. In June 8, 2018, IBM Summit takes back the crown of the fastest supercomputer again. Summit can perform 122.3 PETA 14-point operation per second. applications of supercomputer. Computation intensive applications, intensive applications. Weather forecast, forecast, climate research, quantum mechanical physics, quantum. Molecular modeling, structures, properties of chemical compounds, micro molecules, polymers, and crystal. This is for material. This is the material. This is for physics. This is for weather. For weather. For weather. This is for computation. Computation. Analysis. Analysis. Sorry, I need to answer the phone. Sorry. Right.
老师 what is cryptanalysis 老师老师
Sorry. Well, let's continue the class. This material. This is a weapon simulation. For example, the nuclear weapon is a simulation with the supercomputer. How to make a supercomputer fast? How to make implement a pipeline to the ALU pipeline. Issue multiple instruction in each clock cycle. Use the fastest microprocessor if possible. Use weak processor. Use the cluster of multiprocessor. Each cluster may have from 16 to 64 commercial microprocessors. Use fast interconnection network to connect cluster of processors. Use I/O systems that support high bandwidth. High bandwidth. This is the way we can use to make a super computer fast. Super fast. Processor. Arithmetic logic unit, register and control unit. This is three parts for the of the processor. Processor, ALU, register, and control unit. This is a ALU example. The ALU example. CPU register. CPU register. Control unit. Control unit. Next, I introduce the microcontroller. Microcontroller. This is the main part of this class. Main part. Microcontroller incorporates the processor memory and the many peripheral modules into single VLSI chip. Which means in one microcontroller include processor, memory, and other modules. SRAM and flash memory, peripheral such as the timer, parallel I/O ports, serial communication interface, AD converter, DA converter, and so on, are often included in a microcontroller. From here, we know a microcontroller not just a computer. It's more than a computer. It's more than a computer. Fast memory is used to store program memory, whereas SRAM is used to hold dynamical data. Microcontroller has been used in every applications that require a certain amount of intelligence. Intelligence control for the microcontroller. Next, I introduce the embedded system. A special purpose computer system designed to perform a dedicated function. An embedded system performs one or a few predefined tasks and often include task-specific and hardware and mechanical parts not found in a general-purpose computer. A product designed with a microcontroller or microprocessor that the user can install different software so that the product can perform many different functions and not embedding the product. Not embedding the embedded systems is for just for one task specific for this task specific hardware just for purpose specific task. If we cannot install other software, cannot answer now. For example, cell phone, pad are not embedded product. Embedded product. Wireless sensor network. Wireless sensor network. This is consists of a microcontroller. This wireless sensor network controlled by the microcontroller. WSN consists of distributed independent sensor nodes that are meant to monitor physical or environment conditions. Sensor nodes communicate with each other, exchange information and data while wireless communication. Sensor nodes connect environment information and forward it to a base station. The base station then sends the info to a wired network or activates an alarm or an action depending on the type and the magnitude of data monitored. Wireless sensor network is an important microcontroller systems. The typical application includes weather and forecast monitoring, battlefield surveillance, physical monitoring of environment condition, such as pressure, temperature, vibration, pollutant, tracking human and animals movements in forest and birds. Wireless sensor network may consist of from thousands to hundreds to thousands of sensor nodes. Sensor nodes consist of a radio transceiver with an antenna, or and MCU, a microcontroller unit, and electronical circuits for interfacing with the sensor, memory device, and energy source, usually a battery or a device that can harvest energy. For example, sun energy. It's a wireless sensor. Wireless sensor, the base station has enhanced compatibilities over regular nodes, as they are expected to carry out compound processing. The base station has the strong processor. The main function of a sensor nodes are sensing and sending data. The topology of the wireless sensor network can vary from a simple star network to an advanced multi-hop wireless mesh network. The propagation technology become between hops of the network can be routing of or flooding. This is an example for forest fire alarm systems. It's a yellow node. Yellow node is a sensor node. Tens of thousands of micro sensors are densely distributed in the forest. The sensors cooperate with each other through a wireless network to jointly perform distributed perception tasks and transmit accurate file source information to the information center. This is an example for wireless sensor network. Next, I introduced another example for the microcontroller application. Internet things. LOT, Internet of Things, described the coordination of multiple machines, devices, and appliances are connected to the internet through a multiple network. Objects can be Japanese consumer electronics, vehicles, monitors, and sensors equipped with communication compatibility that allow them to send and receive data. To connect to the internet, every object is required to have an address to identify itself and has a processor to execute the networking protocols and applications. LOT, Internet of Things, brings convenience, comfort, and efficiency to our daily life. Internet of Things can connect everything into the internet. Brings convenience to our daily life. Next, I introduce the memory technology for the computer. Three major memory technology use magnetic, optic, and semiconductor. I don't introduce the memory detailedly. You can read the PPT by yourself. Read the PPT by yourself. There is some concept I need to tell you is the RAM and the ROM. RAM. The information stored in the RAM will be lost if the power off. But the information in the ROM, read-only memory will keep it. This is a memory system operation. A simplified memory system is shown in figure. This is a microprocessor. This is a memory systems. Read, write the memory. Date. This we call the address. This is control. This is date. Three buses. Next, I introduce the program execution. Program execution in the computer. To enable a computer to execute the program immediately after power on, part of the program must be stored in a non-volatile memory. To start up a program, perform system initialization. After system initialization, the start program knows additional programs from secondary storage for execution. Different from ordinary computer, the whole application program of an embedded system is stored in non-volatile memory, ready for execution immediately after power up. Both general purpose computer embedded systems are required to use program counter to keep track of the next instruction to be executed. Both are in computer or other embedded systems are required to use program to counter to keep track of the next instruction to be executed. Program counter we call the PC. Sometimes we call it PC. Is the same to the personal computer. But they have the different meaning. It's a program counter. We use this program counter in the microcontroller to keep the track of the next instruction. Program counter is constructed use D flip-flops similar to the that in figure 1.5. This is a D flip-flop. The program should be designed to support all possible program flow change, i.e. Sequence program execution, conditional unconditional branch jump to certain location. The program count should be forced to fixed location after power on to perform system initialization. Fixed location usually is location 0. Program when the power on after the power on, the program count is set to 0. A possible implementation of program counter that meet these requirements is shown in figure. This figure shows a program counter implementation. I hope you just need to remember the program counter is pointed to pointed to the next instruction. If we want to execute the program, we need to follow this. The value of program counter must be known when the computer is powered up. usually is 0. Usually is 0. The program counters of most microcontroller are forced to 0. Are forced to 0 when they are powered up. Processor starts to execute the instruction from address 0. Address is 0. If you can change the address 0, other address is possible. Other address is possible. Instruction execution process. Read the next instruction from the memory location indicated by the program counter. Decode the fetched instruction into a set of commands or signals for each of the components of a processor. Increment the program counter so that point to the next instruction. Read whatever dates that the instruction require from the memory or input device. The location of these required dates is typically stored within the instruction code. Provide the necessary dates to an ALU or register. If the instruction requires an ALU or specialized hardware to complete the processor instructs the hardware to perform the request operation. That result from ALU back to memory location or to a register or perhaps an output device. Jump back to step 1. This is the process. This is the process of instruction execution. 8051 microcontroller market overview. Developed by Intel in 1980 for use in embedded systems, are very popular in 1980s and 1990s in US and even in China. Many companies licensed the design of 8051 and introduced their own version of 8051. STC microcontroller in China is one of the licensee. 8051 vendor differentiate their product by adding peripherals and even changing the processor design. The original 8051 used the external crystal to generate clock signals to control instruction execution. 12 crystal clock cycles become one machine cycles. 12 crystal clock cycle become one machine cycle. Instruction execution is controlled by machine clock cycles. This is cycles. Critical clock cycle and then machine cycle. Creation cycle. The features of original 8051 MCU. 8 data bus and 8 bits ALU. The 8-bit data bus 8-bit data bus 16-bit address bus data bus address bus which enable 8051 to address up 64 KB of program memory and 64 KB data memory. 128 bytes of on-chip RAM, 4 KB on-chip ROM, 4 KB on-chip ROM, 48 bits by 48 bits bi-direction I/O port 4 and UART module serial port 2 16-bit timer to never interrupt priority interrupt priorities interrupt power saving mode. This is features 8051 MCU. This is features for 8052 bigger RAM on-chip program memory to 8 KB. Add a third 16-bit timer. A third. Other features are identical to the 8051. Here's a summary introduced to the STC microcontroller. We just ignore it. Okay, this is some introduce about the microcontroller. Some knowledge is about the computer, but we know the microcontroller is also a computer, but more than a computer, So if you want to learn something better, you need more knowledge about the computer. So let's have a break. Okay.
Okay, 老师
Let's have a break. Thank you.
You're welcome.
Thank you.
Hello. Hello. Hello, everyone.
Yes, Laushi. Yes,
Hello.
Laushi.
Let's continue our class. Okay.
Yeah, Laushi. Yeah. Let's continue, Laushi.
Last class I introduced some fundamental about microcontroller. Microcontroller. As you can see, you can search the microcontroller online. You can see some chip. Some chip is microcontroller. This is HMEGA microcontroller. From here, you can see microcontroller is related to hardware. Hardware. So you need to use some conditions to debug your design. So if you have some hardware, you can study your microcontroller with the hardware. But if you don't have any hardware about the microcontroller, you can use the software to simulate microcontroller. Here I introduce some software. PROTUS. Use this software to simulate microcontroller. Microcontroller. It's Proton's circuit simulation. Circuit simulation. You can use this software to practice your design. So everyone, you need install this software on your computer. After we learn something, we use this software to simulate your software and your hardware. Software and your hardware. Next, I introduce some hardware about the microcontroller. Microcontroller. Microcontroller principles and application hardware structure of microcontroller This is a 8051 chip 8051 chip. I introduced the logical structure and the signal pins internal memory, parallel I/O, clock circuits, and the timing, working modes. The feature of 8051 core. 8051, the core of MCS 51 devices, the original members of MCS 51 family. Original member. 8-bit extensive Boolean processor, 64 key program memory, 64 key data memory, 4 key B of on-chip program memory, 128 B of on-chip data RAM, 32 bidirectional and individually addressable IO9s, 2 6-bit timer counter, 4 duplex ART serial port, 5 source interrupter structure, with 2 priority levels, on-chip clock oscillator, This is a block diagram of 8051 core, 8051 core. It's a CPU. This is a bus. This is a bus. Interrupter control is under oscillator, and oscillator is connected to the CPU. And the other function RAM timer and bus extend control, I/O port, serial port are all connected to the bus, This is a internal logical structure of 89 C51. This is another 8051 chip. 8051 chip. It's internal logical structure. Here is the CPU. Here is the CPU. Here is the CPU. This is a RAM. This is port 0, port 2, port 3, port 1, port 3. This is a parallel port. Here is the oscillator. This is for timing and control. This is for instruction register. we can name something from here, and this is a function, hardware function. We can learn from this figure, this is a figure about the 80 line S51. It's one of the 8051 one of 8051 chips, one of. You can see there's 40 there's 40 pins, there's 14 pins, 14 pins. We can analyze this these 14 pins from the block of the function, from of the function here. The block down block. This P0, P1, P2, P3, P3. This 8-bit parallel port, this is for oscillate, This is for RAM or ROM. This is for external RAM or ROM. Here is for power source. Here is for power source. Some pins has some pins have alternate function. Here P3.0 alternate function is a serial input port. P3.1 is a serial output port. Here is external interrupt 0, interrupt 2, out in external input, P.6 and P3.7, and it's external data memory write stop and read stop. This is alternate functions for P3 port. Next, I introduce internal data memory. 89C51 has 128 bytes of on-chip RAM. Plus a number of SFR, special function register. SFR, special function register. This is the internal data memory. SFR, direct address only. Here is direct and indirect addressing. From 0 to 7F. This 80 to FF is a special function register. The lower 128 bytes of internal RAM, this area can be divided into three parts. Register area for register bank 0, 1, 2, 3, 1, 2, 3. Bit address area and user RAM, from 30H to 7FH, This direct and indirect address divided into three parts. As you can see, this is on chip RAM. This is 00 register bank. 0 register bank. Register bank 1, 2, 3, 4. 4 register bank. Every register bank has 8 has 8 register. Register. 4 banks of 8 register R0 to R7, R0, R27. This is bank 0, bank 1, bank 2, bank 3, bank 3. From here 20H to 2FH, is a bit address. After that, from 30H to 7FH is user RAM. You can use user RAM from 30H to 7FH. Register bank, bank 0, 1, 2, 3. The address in this area are 0H through 1F. This area is grouped into 4 banks of 8 registers. 2 bits RS1 and RS2 in this register. In this register, there are 2 bits. We named RS1 and RS0 for selecting which register bank is in use. Which means 00 is bank 0. 01 is bank 1. 10 is bank 2. 11 is bank 3. So these 2 bits for selecting register bank. Reset default is to register bank 0, which means if we power on the microcontroller, default is bank 0. Default is bank 0. This allows more efficacious use of code space, since the register instructions are short than instructions that use direct addressing. Reset initialize the stack point to location 07 location 07 stank stank is a special RAM special RAM area for store some dates when the interrupt when the interrupt started when the interrupt is started the microcontroller stores some information into the stack for the interrupt return for the interrupt return. After return, the microcontroller executes the calls from the information stored in the stank. So you need to know the stank is some special RAM for the storage for storage. So if we reset or start the microcontroller, the stack point is to 07H L7H. So in fact, the stack begin from 0H from 0H, but 08H to 1FH is register area that will be used in programming. So we often set stack area in 30H to 7FH 7FH. This is the bit addressable area, which means this area has a byte address and bit address byte bit address. Byte 1 byte has 8 bits. So this is one byte address. There's 8-bit address. 8-bit address. Bit address start from 0H, 0H, but the byte address from 20H, from 20H. We can see here after the bank 4, after the bank 3, after the bank 3, the next address is 20H, 20H. So here is the bit address, bit address. Bit address. This is a byte address. This is a bit address. 0, 1, 2, 3, 4, 5, 7, 8. These bits can be addressed in 2 ways. Bit address, for example, just give the address bit. Byte address, you can use the byte address add plus the point and the bit 25H.0, which means 25 is here. This is 0. 1, 2, 3, 4, 5, 6, 7, 7, 8, almost 7. So 25.0, which means bit address 28H, and 25H.1 is here. 29H bit address. So here the bit address area can be accessed with two types of the address, two types of address. Internal data memory, the known 128 bytes of internal RAM. Apart from the bit address area and this bank working register, we call this working register. Here is the user RAM from 30H to 7FH, 7FH. User RAM space is 80 bytes, 80 bytes, 80 bytes. The address in this area is 30H through 7FH, 7FH. Stack always are arranged in this area, which means after the microcontroller is powered on, we change the stack points to this area, If the stack point has been initialized to this area, enough bytes should be left aside to prevent SP data destruction. You need left enough space, for your data, For 51 serial, the upper 128 bytes is only used as a special function register, and can only be accessed by direct addressing. Address space 80H to FH is for special function register, with special function register. This is a example. Example for the address. For the address, you can see here. Move the AA to. This is assembly language for the microcontroller. It's move 80H comma pound 0AAH, which means move this value to memory address 80H. Use the direct addressing. Use the 80 as the address of P0, but cannot use this one. We will introduce the assembly language next class. On this class, we just introduce the arrangements about the RAM. Special function register. Special function 22 special functions. Function register. There's only one is PC program counter is not addressable. 21 addressable. 21 addressable. Here is the special function register. This is the ACC accumulator or symbol ACC or A. This is B register PSW SP DPTR the date points the date points it's DPL DPH DPL and DPH is 6 bits 16 bits. It's port 0 to port 3 port 0 to port 3 If we want to access the bit, we use the point. There's many special function register. We will learn in the next class. So you just know this is special function registers. Special function registers. The addressable table of bit address of special function register. Here is the symbol for the special function register BA PSW. Here is the bit address for every bit of the special function register. You didn't remember the address. Sometimes we often use the symbol at the point and the number access the bit address. Here is the program status words. This is a special function register. Special functions 8 bits. Every bit has its meaning. This bits this is 0, 1 to 7. 7. This bit CY is for carrying flag. AC is ordinary carrying flag. F0 this is flag 0 available to the use for general purpose. Here is for register bank selector. Here is register bank selector. OV is for overflow. P for parity flag. As a special function register, we use it often. after reset or power on, value of some SFRs are special function registers are PC is 0, SC is 0, B is 0, PSW is 0, SP is 07H, DPTR is 0, SP is special when it's reset, it become 07H, 07H. Stack operation, for saving breakpoints and the scene in invoking a subprogram and interrupt option. Stack point indicates the address of top of stack. We use the instruction push to save the date. Pop to read the date. Pop to read the date. This is save. This is read. Write date. Read date. Push operation. SP add one to SP. Write date. Pop operation. Read date. And SP minus one to SP, -1 to SP. Reset initialize the stack pointer to 07H, 07H. Often set stack area in 30H to 7FH, 7H. This area is for user, so we can set the stack pointer in this area, This is a address assignment, for the 51 serial, 51 serial, 000H to FFH, 4 key memory, 4 key memory. 58 serial from 0 to 1FF, 8 key memory, 8 key memory. After reset, CPU begins execution from location 0, or 0. 5 interrupt vectors are assigned fixed location. The interrupt causes the CPU jump to the related location where it has a non-conditional jump. There has a non-conditional jump. Instruction point to the server's routing, which means we know the arrangement in the ROM, program memory. We call it ROM. Store the memory, store the memory, program memory, store the program memory. So after reset, CPU began execution from 0, and the next space for the interrupt, is fixed, Here is for serial port interrupt. Here is for timer interrupt. This is for internal extra interrupt 1. Here is for timer 0 interrupt. Here is external interrupt 0. So from here we can see the arrangement in the ROM just like this. This is 0 for the CPU to begin the execution. Begins the execution. And here 03H for the interrupt 0. 0B to 012H for the time 0. 13H to 1AH for the external interrupt 1. 1BH to 022H for the time 0 interrupt. 23H to 2AH for serial port interrupt. The other area for the ROM can be used by the user. But here we must use according to the arrangement. According to the arrangement. Next, I introduce the 4 ports. 4 ports. Port 0, port 1, port 2, port 3. Port 3. We use the symbol port 0, 1, P0, 1, 2, 3. Port 1, 3. This is P0 for 8 bits. P0.0 for the first bit of P0. P0.7 for the eighth bits of the P0 of the P0. Each port consists of internal CPU bus, a data output range, two twice-state input buffer, MUX multiplexer, data output driver, and the control unit, control circuit, each port consists of these. We can see this is port 0. This is port 0, port 1, port 2, port 3, port 3. Here is port 3. The 3. Read range, bus, write to range, read pin, address state control, multiplex. This is P0.X pin. P0 pin. Every bit has all these. Have all these. The structure of port 0 to 3. Port 0 to 3. Port 0 has open drain output. It has no internal pull-up resistor. This is important. We need to remember there is no internal pull-up resistor. So when we use port 0, we need an external resistor for the pull-up resistor. This is equivalent circuit of port 0. This is the port 0. Since port 0 pins that are being used as output pins are often drained. In this case, external prolapse and VCC must be connected with the P0 pins. P0 pins. From this figure, we can see if we use P0, we need to add the prolapse resistor. This is the resistor. This is the resistor. This is a VCC. This is the VCC. This is special for the P0. For the P0. The port 1, 2, 3 has an internal pull-up resistor. So the pin is pulled high by the internal pull-up resistors, but can be pulled low by an external source. Pulled high by internal resistor, but pulled low by external source. To be used as an input, the port bit range must contain an 0 or 1, which turns off the output driver. Which means if you want to use these ports as an input, you need first give the 1 to the port, then we can get the input, get the function of input. Port 1, 2, 3 have fixed internal pull-ups, so they are sometimes called quasi bidirection, quasi bidirection ports. Port 0, on the other hand, is considered truly bidirectional, because it flows when configured as an input. This is a high impedance input. After reset, one writes to all port ranges. Here, I introduce some points about how to use the parallel ports from 0 to 3. From 0 to 3.
Hello, may I ask you a question?
After we learn some assembly language, we will know how to operate the ports, how to operate the parallel port.
Okay.
So this is for today's class. Okay. If you have any questions, you can ask. Anyone has questions?
I have a question, Lashi.
Okay.
Lashi, what is the VCC? The one connected with the pull-up resistor on the port 0.
You said ACC?
No, VCC.
VCC is power source.
Voltage control current.
Sorry, I cannot hear you.
Is it the voltage control current? Okay, Laoshi, okay.
You can send me the message, okay?
Okay, Laoshi, okay. I see.
You can send me the message. We cannot hear you.
Okay.
Anyone?
Laoshi, can you hear me now?
If you have no questions, our today's class is over.
Yes, Laoshi. Okay, Laoshi, thank you.
Thank you. You are dismissed.
Bye bye.
Okay, Laoshi, thank you,
Today
Laoshi.
class is over.
It's great to meet you.
Thank you,
Thank you, everyone.
Okay, Laoshi. Laoshi, how
Thank
can
you
I get our video? How can I get our video, class video?
Some students has recorded the
Recording.
videos.
Yeah.
Because
Email.
we have a account on YouTube. You can also upload in the YouTube channel.
Yeah, email.
Just wait for a minute.
Is there anyone who wants to help Laoshi to upload this video on YouTube?
I think email.
I cannot access the YouTube.
Okay. What about Charlie Jal? Hey bro, are you there? Anyone who can,
in our YouTube channel.
who
Tell him.
who can take the responsibility to upload this video on YouTube?
Yes, I will.
Okay,
This
bro. Thank you. Thank you.
this is student can
video.
do it. Can do it. I have given the right to him to
Okay, thank you,
record
teacher.
our meeting. Record our meeting.
Okay.
Okay, Laoshi.
Okay. Class is over.
Convention 很高兴。Bye bye.
Bye bye.
Saif, attendance
ডাকতেছে নাকি সাইফ?